To truly grasp why the photon is so utterly helpless, we have to look at the sheer crushing mass of the radiative zone. This is the vast region wrapping around the sun's core, and it is a monument to density. We are told that space is mostly empty, but inside this zone, emptiness does not exist. Let us zoom in to understand the scale. If you could take a block of the sun's core the size of a standard sugar cube, it would weigh more than a massive lead weight on Earth. Under this extreme compression, the plasma is not a gas. It behaves more like a liquid of incredible thickness. The particles are packed together so tightly that there is simply no room to breathe. Now watch what this implies. This extreme density completely defeats the speed of light. People say light is unstoppable, but density is the ultimate equalizer. Try this right now. Take your hand and wave it through the air. It feels effortless, right? Now imagine trying to wave your hand through a thick jar of cold honey. It resists you, it slows you down. Inside the radiative zone, the photon experiences the cosmic equivalent of trying to swim through solid granite. Every single cubic millimeter contains trillions upon trillions of charged particles, all packed together under the weight of the layers above them. The pressure is so intense that the electrons are squeezed right up against the protons. Because of this, the photon cannot find a single gap. It cannot slip through the cracks because there are no cracks. Here is the twist you did not see coming. This brutal bottleneck is actually a protective shield for our entire solar system. If the sun were hollow, or even just slightly less dense, those high-energy gamma rays would shoot straight out of the core in 2 seconds. They would blast across space and strip the Earth of its atmosphere instantly, turning our planet into a sterile, radiation-baked rock. The crushing density that traps the light is the very thing that tames it. It slows the monster down, domesticating it over thousands of years. But exactly how long has today's sunlight been trapped in this dense, dark maze? To understand that, we have to look at what was happening on our own planet when this light first began its journey. Let that sink in for a second. 30,000 years. That is how long today's light spent inside the sun before it could escape. Let us put that scale into perspective. Think of someone you know. Think of our entire modern world with our towering skyscrapers, our global network, our high-tech gadgets. Now trace time backward. Go past the internet, past the Industrial Revolution, past the Roman Empire, and past the building of the Great Pyramids. Keep going. 30,000 years ago, the Earth was a completely different planet, locked in the grip of the last great ice age. Massive, miles-thick sheets of ice covered North America and northern Europe. Woolly mammoths were wandering the frozen steppes. Early humans were painting wild beasts on dark cave walls. They were huddling around small fires trying to survive the biting cold. Now try this right now. Look up at a patch of blue sky. The warmth you feel this very second was born at that exact moment in the deep, silent dark of the solar core. While those prehistoric humans were hunting to stay alive, this specific light was taking its very first step, slamming into an electron and bouncing backward. It was an incredibly dangerous gamma ray then. Here is the part nobody tells you. As empires rose and fell to dust on Earth, that photon